Hello, my name is Madison Solares, and I'm going to be presenting on electric generators. First off, a generator is a device that converts mechanical energy to electrical energy for use in an external circuit. The source of this mechanical energy may vary widely from a hand crank to an internal combustion engine.
Other sources include steam turbines and water turbines.
Electric power is the rate at which electrical energy is transferred by an electric circuit, and it's usually produced by electric generators. With the use of an electric power grid, this electric power is supplied by the generators to homes and businesses alike. One of the first electromagnetic generators was Michael Faraday's Faraday disc, also known as the first homopolar generator. This generator was developed in 1831 and was not a significant source of power. In fact, it was actually quite inefficient. What was important about the Faraday disc was that it introduced the possibility of generated power through the use of magnetism, a concept that would eventually earn the name dynamo. In addition, Michael Faraday played a huge role in defining the laws of electrodynamics. With Faraday's law, which states that the induced electromotive force in any closed circuit is equal to the negative of the time rate of change of the magnetic flux enclosed by the circuit, scientists are able to predict how a magnetic field will interact with an electric circuit to create an EMF, also known as an electromagnetic induction. In addition, we are able to observe how a changing magnetic field within an electric generator can cause a current to flow through wires through the use of this law. The simple concept is what makes electric generators work and supplies energy to series circuits, parallel circuits, and combination circuits. Series circuits have only
one pathway for the current to travel and are most often used to power batteries and other consumer electronics, such as refrigerators and lamps.
On the other hand, parallel circuits have more than one branch of connection, meaning that the current that travels through the wires can take more than one path to its source. Some examples of items in your home with parallel circuits are electrical outlets and a cell phone battery. Adding to the series and parallel, there are also circuits that contain both kinds of circuits in one. These are called combination circuits. One example of a combination circuit in real life is Christmas lights. Anyway, paired with the topic of current are the numerous factors that can affect the resistance of a substance. Resistance can be defined as the measure of the degree to which a conductor opposes an electric current through that conductor. The degree of resistance can increase or decrease depending on numerous factors, including the temperature of the environment, the length and thickness of wires, and the conductivity of the substance. Because of this, the amount of electricity coming out from the electric generator can vary, and a reduced amount of electricity will travel on to power things. One important thing that needs to be clarified about electric generators is that they do not create electric currents. They simply force the movement of electric charges present in the wire through an external electric circuit. The idea of a reduced amount of electricity ties into Ohm's law, which states the potential difference or voltage across an ideal conductor is proportional to the current through it. With the equation V equals IR, where the V equals to voltage, the I equals to current, and the R equals to the resistance, it becomes much easier for scientists to determine the amount of potential difference that comes from an electric generator. In the end, electric generators are involved in extremely complex situations, yet they supply the energy to power the world.